Identifying areas for enhancement. I'm tasked with pinpointing bugs and enhancing code performance or structure with up to 5 concise comments. Identifying areas for enhancement. I'm thinking about streamlining the reaction test by using a helper function for random targets. Additionally, it's worth considering a single function for removing event listeners in the reaction test. Revisiting code strategies. I'm evaluating the whack-a-mole approach for grid clearing. Also considering CSS transitions instead of set timeout for smoother fade outs and potentially chunking code into modules for clarity.
Okay, so I did a pretty amazing job developing this game. It's called Dopamine Dash, and we went through ChatGPT 4.0 first. So I wrote a quick description of the game, had the, outlined the idea for it. Then we popped it into Auth3 Mini High for the actual code development. Did another stage of improving the instructions of the game. We don't actually have the leaderboard at the moment, but that should be fine. Yeah, and we just told it to build the web application using HTML, CSS, JavaScript, and JSON only. And it did a really good job all in a single file. At the moment, we'll probably have to split it later on. Yeah, it's interesting that it actually provided like a template and then suggested improvements for it. So we actually used that prompt at the end of its response to expand and tweak the code for more minigames. So currently we have basic, so this is like a dopamine rush game. Just do clicks and get some dopamine points. can do quick reaction tests. Can do a quick memory game. So it's actually highlighting the color boxes that you need to repeat. I think it does 3 rounds. Yep. We have a basic whack-a-mole. And then you can buy upgrades, which essentially just make the they just make everything cost more. So you essentially get more bang for your buck, or well, more buck for your bang as you progress with the game. Currently level 6, and it just means that everything costs more, but you also get more points for doing the mini games successfully. It's pretty amazing that it was able to do all that. A bunch of prompts, about 5-6 prompts. Started with GPT-4o, then O3 Mini High actually did the coding, and then we actually placed the code we've sent the code to O1, and it actually was able to spot on figure out what was wrong. Originally the minigame, the round of each game was only a single round, and currently it's looping like three times within each game, so it was able to fix that when asked to do repeated rounds. So trying to explain the levels. No detail. It didn't actually do the reasoning business. So there's no details on that.
So, the text current upgrade level is simply a way to show players which upgrade level they're at. As upgrade level goes up, each click on the main button gains an additional +1 point, on top of base dopamine, streak bonus, etc. This is how you can tell at a glance how strong your click power is getting.
Right, so it's essentially just defining your click power. Okay. So we did a code review with O1 again and found no bugs, but then reviewed the code and made a bunch of suggestions. By the way, everything we do eventually appears on the website. Hey, can you quickly repeat the suggestions as continuous text in the chat? And also update the code, taking all the suggestions into account. So as I said, we started with 4.0. I'm not sure if it's the right thing to do, but we started with 4.0, then jumped onto the high end O3 Mini High, and now fine tuning the game with O1.
Synthesizing suggestions. I'm weaving together the suggestions into a continuous flow of text, considering all recommended code enhancements while adhering to constraints on comments. Pulling together suggestions. I'm combining all coding tips into a coherent flow of text, ensuring a smooth transition between each suggestion. Then, I'll show the code with these ideas seamlessly integrated. Crafting code enhancements. I'm pulling together helper functions to cut down on repetition, highlighting tiles, and managing grid clearing and sound loading, aiming for a smoother and more efficient user experience. Integrating minimal updates. I'm focusing on refining the code with just 5 concise enhancements, streamlining reaction rounds, spawning tiles, refurbishing grid clearing, centralizing area display logic, and tapping into asynchronous sound loading for performance. Setting preload for audio. I'm mapping out a straightforward way to prepare audio files using preload equals auto for each, ensuring efficient sound management while keeping the code clean and effective. Crafting concise functions. I'm developing functions for highlighting tiles, clearing the grid, and managing show, hide logic, keeping the code clean and focused with minimal comments.
Yeah, I'm not sure why I decided to do, oh, well, I asked it to do it in the chat. I thought it will update the code in the canvas and do the response in the chat. We currently have a whopping almost 600 lines of code. Yeah, I'm not sure if anything. Looks like potentially some bits were removed or something. Yeah, the reaction test, it doesn't actually penalize you if you are doing it slowly, and it's giving you the same number of points. Yeah, I'm not sure everything seemed to be working in the same way. Okay, can we also update the code in the canvas based on what we discussed and the improvements that we made? And just make sure to keep all the current functionality. Making sure to keep all the current functionality.
Implementing time-based penalties. The goal is to add time penalties to the reaction test by measuring the time elapsed after setting the target. Rewards will be reduced based on the time taken per click, ensuring fair evaluation. Refining rewards. Clicking within 200 milliseconds retains the maximum reward, while delays beyond 1 second reduce points. This method maintains minimal code alterations by using existing variables. Refining the approach. To ensure consistent code, I'm adjusting the reward formula to subtract the time spent divided by 200, effectively scaling the reward based on reaction time. Enhancing the code. I'm refining the reaction test by integrating the new reward logic into the canvas. This update will ensure the code is more efficient and maintains its core functionality.
It's everything we do eventually appears on this website. Go check it out. Yeah, will be games are good because we can actually see what the AI code generating tools can achieve, what they can do. It's pushing them to the limit.
Your Canvas code has been updated. The reaction test now reduces the reward based on how long it takes to click the target, while preserving the rest of the game's functionality. Let me know if there's anything else you need.
Okay, the code might be shorter because it's removed those comments. Which is fine. We'll do another test quickly before moving on to something else. Okay, so the clicks work okay, and you get 94. That's how many this trick is. We need a description at the bottom of the HTML, that's for sure. Not getting a checkpot too. No, got a checkpot. Is that reaction game? It's not penalizing me for actually taking my time. Ah, it's giving me 0. No, it does now. So it gives me different number of points depending on how quickly I go, which is really nice. It's able to so it's still not hallucinating or anything. It's yeah, the whack-a-mole could also have different number of points. Okay, so not okay, so you're not actually getting points because it keeps moving around, and you're only getting points when you catch it. So that's fine, and you can buy more. So it's not quite clear what happens when you like level 5. But anyway, it looks great. Yeah, it's giving less and less points if you're just taking your time, because I think you can get 10 if you're like super fast. So not entirely sure. Yeah, not entirely sure what does it mean to the current upgrade level. Does it just mean that the upgrade cost is higher, or does it mean anything else? Yeah, we could obviously, yeah, if we can write a description at the bottom of the HTML of instructions, how to play, how the code works, future directions for this game, and a general overview, and also mention how the game was developed using AI. So instead of drinking coffee, you can just play this game. It is free, obviously. We're not doing any. Yeah, it's all faking the points. It's just your dopamine level.
Crafting detailed instructions. I'm laying out tips and guidance for the game, explaining its AI-powered design, gameplay tactics, and future enhancements. This content will be elegantly formatted at the bottom of the HTML, ensuring clarity and accessibility. Piecing together. To include guidance without overloading the code, I'll add a concise section at the bottom detailing the game's AI design and basic instructions, avoiding abundant comments. Introducing the game, I'm adding a new section called Instructions and Overview to the HTML structure. This will include gameplay details, AI development insights, and future plans. Adding a new section. I'm planning to integrate a new HTML block with details on how the game is developed using AI, while keeping the content concise and avoiding any mention of the user or prompt. Rewriting the code. I'll update the HTML to include detailed instructions at the bottom, ensuring all prior functionality remains intact. This involves reintegrating existing code with a new section carefully positioned. Use the main click me button to earn points over time. Build up your streak and try your luck for a jackpot. Reaction test rewards fewer points the slower you click the target. Memory game challenges you to match color sequences for bonus points. Whack-A-Mole requires clicking fast to catch moles for rewards. Upgrading increases your base click power, making each click more valuable. The cost for each upgrade rises as you level up. Future directions include adding more minigames, leaderboards, and synergy between them. This game was partially developed with AI-based assistance and demonstrates interactive JavaScript programming techniques.
deploy the website quickly. Guess that's how long it took to deploy. Actually, originally all this deployment and testing of the website was done by a GPT-4o. So O1. So we're deploying the website, but yeah, if we can just follow along and indicate any issues and give quick explanations. Actually interested in its reasoning.
Setting up and transferring. I'm detailing the script steps. Defining environment variables, setting ownership, deleting destination files, copying new ones, and restarting Apache. Ensuring proper synchronization. I'm noting that for accurate file transfer, the trailing slash should be used with $src_dir. Considering RSYNC options to prevent unexpected directory creation. Below is a breakdown of what each part of the deployment script is, along with potential issues or points to watch out for.
The path should be correct. Yeah, I'm not sure about that, but that the deployment actually works.
If your site is heavily trafficked, a full restart can cause a short interruption. Consider using systemctl reload Apache 2 if you only changed static files, though a restart is usually safe for small sites.
No, it is a small site. Well, relatively. Not sure about small. You mean the content or the traffic? This is what I get as output after the deployment.
This is the total amount of data that was actually sent from your source to the destination. In other words, after RSYNC did its comparison, delta compression, if any, and found which files, parts needed transferring, it ended up sending approximately 735 megabytes over the network, or through your local copy if it's on the same machine.
Yeah, it is on the same machine.
This is the data received back from the destination to your source. Typically, this is overhead, acknowledgements, checksums, or any back and forth communication RSYNC just to confirm file integrity. In short, RSYNC was able to copy around 1.13 gigabytes worth of data by only sending approximately 735 megabytes across the network, plus approximately 48 kilobytes overhead. It managed to do so at an effective speed of about 163 megabytes per second, achieving a 1.54 times speedup compared to a full naive copy of all files. This all indicates that some files likely already existed or partial delta transfers and compression were used, thus saving bandwidth and time.
Yes, some files were existed, but then we actually deleting all the existing files, don't we? Yeah, I'm not sure about that. Isn't a command to delete existing files, so we should have been redeploying the website entirely, like copying, deleting, and then copying it again, like deploying from scratch. Yeah, if you can clarify that. But also, the website is deployed correctly, then seemingly no issues. I mean, maybe you can just go and check the website itself if you like. Try for O1 as internet search or not.
I'm reflecting on the user's method of redeploying the entire website by deleting everything first. The partial speedup from RSYNC might be due to local disk I/O or leftover metadata files. I'm checking the site status and assessing potential leftover files or specific file types like htaccess or hidden files that might be affecting the speedup measurement. Considering directory nuances, I'm curious if subdirectories within the root $dest_dir are being left out. This seems vital for a comprehensive cleanup. The partial speedup might come from cached data or other leftover elements. Understanding the cause. I'm noting that the partial speedup might be due to rsync's local disk-based optimization, compression, or leftover directories and symlinks, especially since hidden files weren't deleted. Spotting speedup factors. Okay, let me see. The speedup might stem from compression or leftover hidden files and directories, as the total uncompressed website size exceeds the partially transferred compressed data. Here's a more detailed explanation about what's happening with your deployment, specifically why RSYNC might report a speedup, even though you're removing all files before copying again, and whether you really are deploying from scratch. Your command is sudo ermrf $dest_dir asterisk. Using asterisk will not remove hidden files, folders, like htaccess.get, or any file name that starts with a dot. Therefore, if your destination folder has hidden items, RSYNC might see that some files already exist and skip recopying or only transfer partial data. If you truly want to remove everything, you need something like
This is dangerous. This is safe, okay. Recreate the directory. Okay, the first one is commented out. Why is this one dangerous?
Even if you did remove all files, Z compression can shrink 1.1 gigabytes of data down to approximately 735 megabytes in transit. RSYNC calculates the total size of all files uncompressed, approximately equals 1.13 gigabytes, versus how much data it actually sent, approximately equals 735 megabytes. This alone can yield a speedup ratio. Speedup doesn't necessarily mean partial file skipping. It just means the ratio of uncompressed size, transferred size. Possible local, short-circuit, optimization, if on the same machine. If the source and destination are on the same machine, RSYNC can optimize data transfer since it's really just reading from one directory and writing to another on the local file system. But the main factor is usually compression if you explicitly used Z.
Okay, so we updated the deployment script.
I'm examining a script that removes a directory, creates a new one, and copies files. The RSYNC output shows a speedup of 1.54, likely due to compression. Here's why you're still seeing a speedup of about 1.54 even though you're now deleting the entire directory and recreating it from scratch. No more partial skips. Because you're removing the entire directory, ermrf $dest_dir, there's no older data for RSYNC to skip. You truly are copying everything from scratch. The speedup you see is purely from compression, not from reusing old chunks of data. Is a safer approach because you remove the folder itself and immediately recreate it. Less chance of messing up a wildcard and nuking the wrong path. You are deploying from a totally clean slate each time. The speedup number simply reflects how much data is saved by compression, not by skipping existing files. Everything looks good. Your script ensures you have a fresh empty directory, copies the new site, sets correct permissions, and restarts Apache.
Okay, anyhow, the deployment works okay. The website is up and running. And yeah, everything seemed to work fine. But did you actually check the website, or you do not have internet access or something, or trouble doing assessment to the actual URL?
Checking the website. As a language model, I don't have live internet browsing capabilities, so I can't directly visit HTTP URL in real time to confirm. However, from the information you provided, no error messages, proper ownership and permissions, and an Apache restart, everything suggests the deployment worked correctly. If you've already visited the site in your own browser and it loads correctly, that confirms the deployment script is functioning as intended.
Well, okay, we also have this Python script that checks the website. While we're running the script, can you actually, while we're running the script locally and getting the report, can you actually overview this Python script and what it does? and potentially if any checks are missing and how the test can be improved. Just explain in plain text, don't generate any code yet. Code is important, so let's actually pop it into Canvas. Let's start a canvas.
Previewing the script, I'm starting to break down a Python script that constructs a sitemap for a website, excluding specific directories. It handles requests, logs errors, and builds the sitemap. Establishing page details. I'm setting up functions to asynchronously fetch page details, identify errors, log them, and gather metadata like titles or descriptions, efficiently handling various page status codes. Executing the main function. I'm gathering landing page links, generating a sitemap, cross-checking links, logging discrepancies, and assembling the final sitemap into a file. Progress is steady and exciting. Detailing the process. The script scans directories, builds sitemaps with concurrency, and logs HTML errors. It compares landing page links to directory-based sitemaps, logging discrepancies and saving results. Identifying areas for enhancement. I'm noting missing checks like broken links, content types, canonical links, deeper scanning, and performance metrics. This highlights an opportunity to refine the script further. Evaluating script efficiency. I'm mapping out SEO metadata, best practice tags, structured logging, and retry mechanisms. Also noting the necessity of validating directory structures to ensure accuracy. Here's an overview of what the script is doing, along with some ideas about what checks might be missing and how you might improve the tests. Uses OS, datetime, IOTTP, Beautiful Soup, Asyncio, and collections to handle file system operations, network requests, HTML parsing, concurrency, and error logging. The actual directories found in the local file system, interpreted as URLs, and the links discovered on the main landing page. It then reports errors for pages with suspicious content, missing less than title greater than, less than meta greater than tags, or certain HTTP status codes. It also logs if a URL is in the sitemap but not referenced on the landing page. Right now, the script only scans directories, top level, and the single landing page as anchors. It might miss pages that live in subfolders of subfolders or are linked from deeper within the site.
Okay, we don't actually have subfolders. It meant to be like a flat website. So like one level So that should be okay. We don't need the deeper link crawling.
The script flags a page if certain keywords appear or if it's missing meta information, but it doesn't check whether all internal links on that page are valid, e.g., scanning each link on the page to see if it leads to a 404. You could extend this to do a more thorough link validation.
Again, I would not worry about the internal link integrity for now. I mean, it's a good idea. How difficult would it be? Because yes, some pages do have links, but some links are external. So should we treat them differently if it's a link to the same website or external website? I'm not sure.
If your site references images, CSS, scripts, etc., you might want to confirm that these resources return a successful status, e.g., 200 OK, and don't 404 or redirect incorrectly.
Yeah, checking that resources exist sounds like a great idea.
Currently, the script checks for less than title greater than and less than metaname equals, description, greater than, but you might also check for less than metaname equals, robots, greater than, canonical tags, less than link rel equals, canonical, greater than, or others considered important for SEO.
Now don't worry about the canonical or SEO tags. I mean, we're actually checking for different tags. So yeah, we are checking for description, which is important. Then can we also check for keywords, that keywords exist? Check for author and published date as well. So yeah, just those will be sufficient for now.
Although likely out of scope for a simple sitemap generator, checking load time or page size beyond just short text, less than 1,000 characters, could be beneficial in some contexts.
Yeah, we are checking for short text because we essentially want the description on the page. We want to make sure all the pages have enough text describing what is it the page does. So we're flagging that as an error if there's too little text. But yes, we might check for excessive load time or excessive page size as well. So if it's too large, but I guess with page size, do we need to also check if it's too small? That might indicate a problem as well, wouldn't it?
If your site has custom error pages, e.g., custom 404 or 500 pages that do not contain the text, error, or not found, you might need additional logic to detect those.
No, we don't currently have any custom error pages, so don't worry about that for now.
If you encounter status codes like 429, too many requests, or intermittent 5xx errors, you might want to automatically retry after a delay rather than just logging the error.
Yeah, can you explain number 7? I'm not sure how we go about it, but it sounds like if we, it feels like with the retry logic, if we got an error on the first go, we might as well log it because it's a strong indication that something is wrong.
If HTTPS is mandatory, you might check that the URLs are using HTTPS, and if you need to verify certificate validity or expiration, that can be an added check.
Now the certificate checks should be working fine for now. maybe just, yeah, I'm not sure if we need to check that or not.
Structured logging. Instead of writing plain text logs, you could consider a structured format, like JSON, for easier parsing and reporting later.
Yeah, more structured logging sounds really good. Yeah, like a JSON format sounds great.
More granular error reporting. Right now, all errors go into a single log file. Splitting them, e.g., one for warnings, one for critical errors, can help triage.
Yeah, for now, I don't expect too many errors, so if we can split them within the same JSON file, so the errors and the warnings can go into a single JSON file, that should be okay.
Pagination or multi-level directory handling. Consider if you need to recursively scan subdirectories to produce a truly comprehensive sitemap. Currently, the script is limited to one directory level.
Yeah, one directory level is fine for now. So leave that one as is.
Add command line arguments. If this script is intended for multiple sites or directories, consider adding a CLI interface for flexibility. Parallelization versus rate limits. The script uses a semaphore of max_concurrent_tasks equals 10. Adjusting that or making it configurable could be important if the site is sensitive to too many requests.
Yeah, can you explain the maximum concurrent tasks? So currently set at 10, it seemed to work okay. So I don't think that's a problem.
Automated testing. You could create test directories or mock servers to automatically verify that your script logs the correct outcomes for known conditions, missing meta tags, forced errors, etc.
Yeah, can you just explain the automated testing some more? Just expand on it. And don't change the code yet. Just generate the text response without any code.
Overall, this script provides a decent starting point for generating a sitemap from a local directory structure and comparing it to the links actually visible on a single landing page. It does a good job logging common problems, missing less than title greater than, short page content, error keywords, suspicious status codes. If you need more comprehensive site coverage or deeper link analysis, consider expanding the crawl logic and adding more robust checks and retries.
Yeah, that's instead of drinking coffee. Well, I'm also drinking coffee, but this dopamine dash rush game also helps. And it should be already deployed. Yes, it is. So you can play it as well. Currently we're doing a test for the website.
Here's some detail on how you could approach automated testing for this script. The overall goal is to give you confidence that the script does what you expect, logs the right messages, saves files, parses pages, etc., under various scenarios. You're not modifying the script itself. Rather, you'd set up a testing framework or controlled environment in which to run it and verify its behavior. Automated testing means you have a repeatable process, like unit tests or integration tests, that check specific conditions automatically, without having to manually run the script and verify output each time. Typically, these tests run in a continuous integration pipeline or on a local test environment so you catch issues early and ensure consistent behavior as the code changes. Since your script involves network requests, IOTTP, and file I/O, automated tests often rely on mocking, patching network calls so you can simulate specific responses, like 200, 404, 500, slow responses, missing elements, etc., rather than making real requests. Temporary or test directories so you can inspect exactly what is written to sitemap.xml, the error files, or any logs the script generates.
Okay, so generally I'm happy to run the test myself, so manually, after redeploying the website.
For each test scenario, you can store a reference version of sitemap.xml and any relevant logs that you expect the script to produce. After the script runs, compare the actual results to the expected ones. You mentioned how #7 retry logic might not be strictly necessary because a single error is a strong indication something is wrong. That's totally valid, but if you ever do want to test something like a retry mechanism, you could simulate a 429 or 503 on the first request, but a 200 if retried. Confirm that your code actually waits and re-requests the URL, then logs the final outcome appropriately. If you're not planning to implement retries right now, there's no need to do this. It's just something to consider if you ever expand your script. Automated testing involves crafting a controlled environment, like a local server plus test directories, or mocking out external dependencies, HTTP requests, to see if your script does what you expect under various conditions. Unit tests focus on individual functions, integration tests exercise the script as a whole, and you can verify outputs by comparing them against known, golden files, or by parsing structured logs. This approach ensures reliability, makes it easier to catch regressions, and eliminates repetitive manual checks.
Okay, don't worry about automating the test. Just let's go over the other items that I mentioned before. Again, just in the chat, don't generate any code yet.
Below is a recap of the other areas we discussed, tying them back to the earlier points you mentioned. Since you said you're not looking to implement or modify the code yet, this is just a high-level discussion of each item.
Okay, we did hit the O1 limit. I wonder if O3 still works. Well, 4.0 should work.
Handling internal versus external links. Why consider it? Sometimes you only want to validate links pointing to your domain, internal, and ignore errors that occur when pointing to external resources, like social media or third-party sites, because you have limited control over those. How difficult to implement? Basic approach. Whenever you see in less than href equals, greater than, check if the domain matches bionichaos.com. If it does, treat it like an internal link and run checks. If not, optionally ignore or log at a lower priority, e.g., external link not guaranteed to be available. Complex approach. Actually attempt to get request for external links. This can lead to more overhead and potential false positives if an external site is down or blocking you. Given your current script is primarily about verifying pages on your own domain, you can skip or do only minimal checks for external links unless it becomes a bigger concern.
Okay, we're going places now, but well, primarily, so O1, we run out of tokens. Okay, so some great ideas with if we can just check for internal links, checking that it's the same domain. So only testing if bionichaos.com links on any page are correct and working and not returning an error. That should be great.
Checking resource existence, images, CSS, scripts. Reason to do it. If a page has less than img_src equals some image.jpg, greater than or less than script src equals some script js, greater than, you might want to ensure the resource actually resolves, i.e., returns 200 OK. This helps catch broken images or missing static files. Possible approach. Parse out all the less than img greater than, less than script greater than, less than link rel equals, stylesheet, href equals, greater than, etc. For each resource URL that is local, perform a quick head or get request to confirm it's not 404 or 403. Considerations. Similar to the internal-external link split, you'd usually only do this for resources on your own domain. Could be time-consuming if you have lots of assets, so you might limit concurrency or skip large files if that's not a big concern.
Yeah, so checking with checking resources internally only on my own server sounds good.
Keywords meta tag. Once considered standard for SEO, these are less important now, but if you specifically want to ensure a less than meta name equals keywords greater than tag is present, you can do that similarly to how you check for less than meta name equals description greater than.
Yeah, checking for meta name keywords is a good idea.
Currently, you check if the page text is less than 1,000 characters to flag it as potentially missing content. You could also check if the total downloaded size is extremely large, e.g., more than a certain MB threshold, to flag performance concerns. You could measure how long the GET request takes to flag slow pages. Caveat. Large is relative. Some pages, like ones with big images or streaming content, might intentionally be larger, so these checks can create noise if not tuned properly.
Yeah, checking if the downloaded size is too large is a good idea. And how long it takes to get a response from the page.
Implementation. If you wanted to add a retry, you'd catch those retriable status codes and retry the request after a short delay, e.g., a few seconds. Or you might limit the total retry count so you don't spam the server. Conclusion. If you consider a single error enough of an indication that something's wrong, you can skip retry logic. If you frequently see temporary spikes, e.g., 429 rate limiting from your server, you might want a small retry mechanism.
Okay, a small retry mechanism, if absolutely necessary, sounds good.
Current. You log text messages into sitemap_error_log.txt. What changes with JSON? Instead of writing free form lines, you could write each logged entry as a JSON object, such as easier to parse automatically or load into analytics logging tools. More structured approach to tracking fields like status code, timestamp, URL, or any custom classification, e.g., warning versus error.
Yeah, the JSON file instead of a text file sounds great.
You mentioned your certificate is probably fine right now, and indeed if IOTTP or your environment sees an invalid certificate, you typically get an SSL error. Additional deeper checks, like certificate expiration date or domain mismatch, might be out of scope for a basic sitemap validation script, but it's something to keep in mind if you want more robust SSL monitoring. It sounds like you've got a clear picture of which things you do, and don't want to address right now. You can keep the script focused on top-level directories, internal page checks, essential meta tags, and short text detection. If you expand in the future, you could incorporate additional checks for external resources, advanced error handling, or structured logging. Just weigh the complexity against how frequently you need those features.
Okay, actually, can we also include the simple SSL check just for the entire website? Once in the code, not for each page. So now the main thing, can you generate instructions for another code developer to do all the coding from scratch? The instructions should not include any code. I will be, however, adding the current Python code that I have as a reference, but the coder should be redoing all the script from zero, from scratch. Can you write standalone instructions for that? Text only. So we're back to 4.0.
Here are the standalone instructions for a developer to rewrite the entire script from scratch, incorporating the requested features while using the current script only as a reference. These instructions assume the developer will start from a blank slate but will implement all the functionality required.
Interestingly, with O3 it didn't time out, only O1 did.
Develop a Python-based asynchronous script that generates a sitemap for a flat structured website and validates its pages based on multiple criteria. The script should scan a specified root directory, representing the website structure, generate a sitemap.xml file listing all discovered pages, perform checks on each web page, including HTTP response status, presence of essential metadata, title, meta description, meta keywords, detection of short page content, detection of internal links and their validity, detection of missing internal resources, images, scripts, style sheets, response time and potential large page sizes, a simple SSL check, once for the entire website. All errors and warnings should be logged in JSON format instead of plain text. Core functionalities to implement 2.1, sitemap generation. The script should scan the website directory and list all top-level HTML pages. Each discovered page should be added to an XML sitemap, including less than lock greater than URL of the page, less than last mod greater than last modified date from the file system. The sitemap should be saved as sitemap.xml.
It seems like we lost the text to speech. Anyway, we have the instructions for a Python script, the generation from scratch that will test the website. Because we are deploying new things and need to make sure everything is in place. And interestingly, we got a timeout for O1 until, I'm not sure what time it is. It might be US time, not local time. That's interesting. Some random time tomorrow. Yeah. I think it will just reset. I assume it will just reset tomorrow. But interestingly, all three didn't time out. So I'll be using that. Just not sure if we actually need the current script or not. So I have this current Python script that works okay, but we would like, so that's just for your reference, and we would like a new Python script that you would develop from scratch. Are you happy to do that? The current Python script and the instructions for the development are below. Okay, so we have the prompt. So the instructions are actually without referencing the existing script. That's interesting. I'm not sure how to go about. Do we need the existing code or not? Maybe we don't actually need the existing code. Okay, I would not provide the existing code. But let me know if you actually need the current Python code that is working. Again, I would like you to regenerate the Python script that checks my website. The Python code should be generated from zero, from scratch. Get a bit convoluted, well, mainly because we lost the access to O1. And we lost the text to speech as well. It's not going great, is it? Okay, so what do we have? We have a bunch of libraries. We're checking a threshold for size of the page. We're generating the sitemap. Page validation. Internal links validation. resource validation, so any files, styling files and things like that. A one-time certificate, SSL certificate check, that's nice. They refreshed the page with the... Nope. Hey, can you provide the continuous text summary? Forgot to mention without the code.
Below is a continuous text summary of the script. This Python script is a fully asynchronous tool designed to both generate a sitemap and validate the pages of a flat structured website. It begins by scanning a specified root directory for HTML files, extracting their last modified dates, and then constructing a sitemap.xml file that lists each page's URL and modification timestamp. Using asynchronous HTTP requests powered by AIOTP, the script fetches each page and monitors its response time, status code, and size. It performs detailed content checks by verifying that each page includes essential metadata such as a title tag, meta name equals description, and meta naming keywords, along with ensuring that there is a minimum amount of text content. Additionally, the script examines all internal links and embedded resources, including images, JavaScript files, and style sheets, to confirm that they are accessible and not broken. For performance monitoring, it logs warnings for pages with slow responses, unusually large sizes, or unexpectedly small sizes that might indicate missing content. Before finishing, the tool conducts a one-time SSL certificate check for the website's domain, validating the certificate's expiry and legitimacy. Throughout the entire process, all issues, ranging from errors to warnings, are recorded in a structured JSON log file that includes details such as timestamps, URLs, status codes, and response times. Finally, upon completion, the script outputs a summary that highlights the total number of errors and warnings detected during the validation process.
Yeah, can you actually look at the code that we currently have and use the same directories, folder structure, so the Python code actually works without any input, without requesting input variables. Similar to the code provided below. The old version is 185 lines of code. The new one is 327, so it's quite a difference, obviously. Okay, the third version is somewhere in between. Main question, does it actually work? It's doing some rubbish. Why is it exporting rubbish? Yeah, I don't like it. So can you just fall back to the description, to the instructions for code development? The Python code that I shared is just for reference, so you don't have to rely on it. Yeah, not sure why it's such a problem. Yeah, that code didn't work. I have some mixed results with this current code generating model. It's all seem legit, but yeah, I'm getting some rubbish out when actually running it. Hey, can you double check the code and find any issues? The code revision. Hey, I'm happy to try it out. Otherwise, we just rely on the old version. Let's just make sure it's still running okay. It's nice and quick, so. Yep, got the error logs. Yeah, that's the new stuff that is coming up on the website. Some actually physics simulations work pretty well. Again, that was O3 mini, what would X high. Gravity works fine, which is pretty amazing. Yeah, zero gravity. H-ball has its own frequency. What's my brain doing at the moment? About 3 or 4 balls up in the air. Spinning fast. Can slow down a bit. Try lowering the gravity. Yeah, I'm actually making a new music generator using some machine learning and stuff, because well, all the games we're doing, they're actually there for a reason. They actually quite useful, first of all, to try and push the code generating models. Second, we will be using like the same principles that we have in the games, we'll be using for actually displaying biomedical data later on. So one example is this particle motion model. You could be actually reviewing time series data that way. So you could have the number of channels as your number of particles, and this will be like a seizure in epileptic seizure in EEG. This will be like normal activity, this will be like your sleep or whatever. So all the games are important that way. Yeah, obviously music has a lot of relevance to, well, time series data processing. So this one actually has a model, an underlying model. That will be working in the background. Yeah, currently the model is not there because we haven't trained a Python script, the TensorFlow. It's interesting that this tab is working even if you're not on the tab itself. That's pretty nice because other tools don't work that way. But it's a nice bug that is a feature. So I have this code that meant to be checking the website. .209 lines of code. Let's try running it. sitemap created successfully. Okay, the sitemap looks legit. Still testing some new games that will actually make sense later on. So running in your browser, by the way, at just 40 megabytes. It's pretty amazing. Just pushing the site to see what it can do. Yeah, what have we mentioned today? I'll just pop the links in the chat for you to play with. Not enough to upgrade. This is meant to be an XML. Yeah, we might have to finish this later on. Yeah, this one seems to be more extensive. A check. I thought this would be in an XML file. I assume all that is there for a reason. Is because one of the applications is faulty. Anyhow, we'll continue this next time. Let me know if there's any questions. Check the website, and I'll see you in a bit. Bye.